Okay, hello. So now let us solve the problems in quiz 1 to take lessons from your mistakes. Okay, let us read the first question. Uh, Question number 1. The number that you see here, 15 over 32 times 28 over 75 minus 1 over 20, in its simplest possible form is equal. So you have to calculate this, put it in its simplest possible form, and then type it here. Okay, so let us do it on the board now. Okay, I'm supposed to do this, and you know that the calculator is not allowed for this quiz. Here, you need to know two lessons here. One, I have two operations, multiplication and subtraction. You know the priority is given with multiplication. And the other thing is that, of course, if you don't want to appreciate the role of simplification here, then you will be in trouble, because then you have to multiply 15 by 28, which is not that obvious. You also need to do a harder one, 32 by 75. But the whole problem in this question, which is an E-level question, is this is testing your knowledge about the priority of operations and if you know how to simplify things before proceeding a multiplication. So you know that if I have a multiplication, I have to ask myself, is it possible to simplify in vertical manner? Is there any common factor between these two? The answer is no. If there is any common factor between these two, the answer is no. But there's another type of simplification that you need to know when you are multiplying fractions, and that is if it is possible to simplify in cross-manner way. And you immediately see that it's possible. Because 15 to 15 is 1 times, 75 to 15 is 5 times. If that is hard for you, you cannot do it in one go. You can do it in several steps. For example, you can say that first I divide this by 3, it becomes 5 times, this becomes 25 times, and then you simplify by 5, it becomes 1 times, it becomes 5 times, okay? But anyway, if you are good in calculations, I wouldn't think that it's a very hard one. 15 to 15, 1 time, 75 to 15, 5 times, and we also can simplify these two by 4, yes? I would say that 28 by 4 is 7 times, 32 by 4 is 8 times, okay? So then what happens? I will continue like this. 1 multiplied by 7, 7, 8 multiplied by 5, 40, and then I have minus 1 over 20. So the multiplication is done very simply, and as you see, no calculator is needed at all. And then I have to make the denominators the same, so what I will do, the common denominator is 40, so I do not change anything here, but I would put minus, instead of 20 again, I put 40. Then I ask myself how 20 turned into 40 by multiplying it by 2. So I multiply its numerator by 2 as well, so it becomes 2. So in other words, I am rescaling this fraction by multiple of 2. So on the one hand, I am not changing anything because 2 over 40 is the same number. On the other hand, I have the same denominators, so I can put the same denominator 40 and subtract these numbers because that's subtraction. So 7 minus 2. So the answer becomes 5 over 40. Even though technically speaking this answer is completely right, but you are not allowed to put this number there because if you look back here, this red part asking you for the simplest possible form. And the simplest possible form here is not 4 over 40, it is 1 over 8. So this is the number that you are expected to type within the empty box. Okay, now let us go to the second question. Question number 2. The fraction in its simplest possible form that must be subtracted from 7 over 12 so that the difference becomes 1 over 4 is equal to, you are supposed to find it and type it here. Okay? Okay, so I am looking for a fraction. Let me put a question mark for that fraction so that if I subtract this fraction from 7 over 12, so this is the meaning. I want to find a fraction so that when I take this off from 7 over 12, the answer becomes 1 over 4. This is the question mark that I want to answer. Okay, might be this is a little bit tricky. When I say I subtract that fraction from 7 over 12, I have to write 7 over 12 minus this. So let me just review it here. If I ask you to read this, if you read this from left to right, this is A minus B. But what does it mean? It means I am taking B from A. So I am subtracting B from A. So if I want to subtract B from A, I have to write A minus B. If I want you to write B minus A, then I have to say I am subtracting A from B. So the question mark here, I am looking for a fraction so that when I subtract the fraction from 7 over 12, the answer becomes 1 over 4. Okay? And that is easy, yes? For example, let us say that I ask you this. What is the number so that when I subtract this number from 7, the answer becomes 4? It's very simple. Of course, this is so simple that you can guess that number is 3. But let us assume that we cannot guess. How can I find that? I can say that, okay, 7 minus this number that you see is supposed to be my question mark. With the same logic, the question mark that I'm looking for this in this problem is this number minus 1 over 4. That's it. So you need to do just this subtraction. And of course the denominators are not the same, so I make the LCD, but LCD between 12 and 4 is just 12. So I copy and paste the first one with denominator 12, but then I rescale this fraction by a factor of 3, so this becomes 3 over 12. And now the denominators are the same, so I subtract these numbers. 7 minus 3 is 4 over 12. But because the problem is asking for the simplest possible form, then you simplify by 4, and the answer is 1/3. 1/3, yes? So you need to put 1/3 here. Yes? Okay, now let us go to the next question. This is the last E-level question. We are supposed to calculate this and type the answer here. If nothing is said, it means do it in the simplest possible form. Okay, now let us do this one. This is the last E-level question of this quiz. So you know that this is testing your knowledge about if you know if I raise 1 or minus 1 to an odd or even power, what happens? If I raise a number, any number to power 0, what happens? Okay, so we know that minus 1 to power 100, okay, it becomes 1. Why? Because the exponent is even. Technically, it means that you take minus 1, multiply it by itself 100 times. But if you multiply minus 1 even number of times, all the minus signs are cancelled, and what is left for you is just 1. Because you multiply minus 1 by another minus 1, it becomes 1. You multiply 1 by minus 1, it becomes minus 1, and you continue so forth. The final answer becomes 1. And if I ask you what is 1 to power 99, it means you take 1 multiplied by itself 99 times, but of course the answer becomes 1. And the next one is minus 1 to the power of 271. But 271 is an odd number. So when I multiply minus 1 by itself odd number of times, it becomes minus 1. Yes? And then finally the last number, 0.293 to the power of 0. It doesn't matter what type of number you have, any number to power 0 is 1. So this number also becomes 1. So now if I want to answer the question mark, so don't get confused here because of the minus signs. So this one, you see, this one itself, I take it off and put 1, okay? But after this orange boundary, what do you see? You see a minus sign, so I put it. But instead of this one, I have 1, so it becomes minus 1. And then I have a minus sign after this orange boundary. I put it, but instead of this one, I put minus 1. So minus is minus, but this one itself is also minus 1. So it becomes minus 1. And then I have plus, and then this number is just 1. And this is a very simple task now. because 1 minus 1 is completely gone. 1 minus 1 is 0. Minus minus 1 is plus 1. And I have plus another 1. So the correct answer to this problem is positive 2. Okay, let us go to the next problem. Question number 4. This is the first C-level question. Consider the following number. Write the simplest possible form of this number in the following empty box. Okay, so as you see, I have two pairs of brackets. It prioritized this addition and this subtraction, and then I divide them, and then when I got the result up to here, I add this, I do this last addition, because division has priority over addition. So let me do it on the board. Okay, so let us do this step by step. Let us concentrate on this first one. Okay, so the first thing that you need to do is this is a mixed fraction. I want to write it as a proper fraction. So don't get confused with this minus sign. If you say 6 times minus 2, minus 12 plus 5 is minus 7, then you write minus 7 over 6. That is not correct. So be careful. When I say 2, 5 over 6, what do I mean by this combination? I mean 6 times 2 plus 5, 17 over 6. When I put a minus sign here, this minus sign is not just for 2. It means whatever this number is, I am changing the sign from positive to negative. Okay? So if this minus sign is distracting you, ignore it for the time being. Write this in a proper form and then put a minus sign behind it. Okay? So what do I mean by that? So this becomes 6 times 2, 12, plus 5, 17 over 6. But now the problem is not this number, is minus this number. So minus this number is also minus this number. Okay? So don't do this. And minus 2, 5 over 6. If you say 6 times minus 2 is minus 12 plus 5 over 6, then you will get minus 7 over 6. That is not correct. That is correct. Okay? And then what is the next one? The next one is 3, 1 over 2, which is 6 plus 1, 7 over 2. Okay? That's very simple. So if you don't mind, let me make it clear. So let me give this number 1. If I want you to calculate number 1, now it is simple, because the first part is this number, plus the second one is that number. But I have 6 and 2. The common denominator is 6. So what I will do, I put the minus sign with 6. I put plus with 6 again. But 6, nothing has changed, so it becomes 17 again. But 2 has changed to 6 by being multiplied by 3. I multiply this by 3, so it becomes 21. Then you see this is minus 17, this is plus 21, the denominator is 6. So minus 17 plus 21 is 4. But because we always simplify things, I simplify by 2, it becomes 2/3. Okay, so that is number to the first part. For the second part, so if you don't mind, let me also call this number 2. Okay, so I would write 2 here. Minus 1 over 9. This is very simple. Instead of minus 1, I have an invisible denominator, which is 1, but I want to have the common denominator to be 9. So I have a minus sign here, I put a 9 for this, minus sign here, I put a 9 there, and then I would say nothing has changed here, so I'm not allowed to touch the numerator. But here, the invisible denominator was 1, now it has changed to 9 by being multiplied by 9. So I multiply the numerator by 9 as well. Yes, these are simple things. You can do them quickly. I don't really need to explain that much, hopefully. Okay, then what happens? The denominator is 9. I have minus 9 minus 1. But minus 9 minus 1 is minus 10 over 9. So this is the answer to the second part. And then finally, the answer to the third part is very simple. If I call this one the third part, okay, and let me also clean this, not to distract you, because that was the wrong one. Okay, so number 3, you can immediately do that. 5 times 3, 18, 5 times 3, 15, plus 3, 18. So it becomes 18 over 5. And then finally, the whole question mark, so let me call the question mark for the question, I have to glue them in one place, yes? Instead of 1, I put what? 2 over 3. After that, I have division. After that, part 2. Part 2 is minus 10 over 9. And then after that, plus part 3. But part 3 is this one, so it becomes plus 18 over 5. Yes? If I can answer this question mark, I do. But again, I have a division and addition. We know division has priority over addition. And if I want to divide two fractions, I copy and paste the fraction, the first fraction. I change division to multiplication, but I have to swap these. So it becomes 9 over minus 10, and then plus 18 over 5. But what happens here now? Again, don't immediately multiply, even though the numbers are fairly simple. But I want you to train to make your brain conditional for simplifying first and then continuing, okay? So here, I would say 2 to 2 1 times, minus 10 to 2 minus 5 times, 3 to 3 1 time, and then 9 to 3 3 times. And then 1 times 3 is just simply 3. 1 times minus 5 is just simply minus 5. But instead of putting minus 5 down there, I put the minus sign up there. There's no difference because I want to keep the denominators the same. And then the rest of it I copy and paste, but then it becomes extremely simple. Minus 3, the denominators are the same. Minus 3 plus 18 is 15. But 15 over 5 is just simply 3. So the answer to the question mark of this problem is very simple to type, just 3. You type the 3 in the empty box here. Okay, so now let us go to the next question. Question number 5. Consider the following number. Simplify this number and write a final answer in decimal form in the following empty box. Okay, so let me write it on the board so that we can do it together. Okay, so let me see if I have written everything right. Yes. So do you remember when I was teaching you, I told you that this is a negative power. In principle, you can use the rule of negative powers. Which one is that? A to power minus n can be written as 1 over a to power n. And then here, 2/3 is playing the role of a, and minus 2 is playing the role of minus n. Of course, you can always do everything from scratch, but I don't recommend that. Of course, I always ask you to learn, to understand, but sometimes you have to learn and remember, most of the time. Otherwise, that would be problematic. So if you remember, when I was teaching you, I tried to convince you that if I have a fraction to a negative power, of course you can use that formula, but the fastest way to do is to remember. It's not in the formula sheet, but I hope that I could teach you in a proper way that you can understand. But after understanding, you have to learn how to do it faster. So I immediately swap these two, and then I make this one n. So I take the minus sign. Okay, so remember that. It's not a hard thing to remember, even though it's not in the formula sheet, okay? So I want to use it. So then I would say that, okay, 2/3 to the power of minus 2 can be immediately written in this way. I swap them, and then I make it positive 2. And then you know what to do here. This 1 to power 2 It's another fraction rule, as a power rule, which we have it in the formula sheet, by the way. So if I have a to power b, a over b to power n, I can write the numerator to power n, denominator to power n. Well, I will do the same thing here. This becomes 3 to power 2, and then 2 to power 2. But 3 to power 2 means 3 times 3, which is 9. 2 to the power 2 means 2 times 2, which is 4. Okay, so the first part is done here. The second part, okay? So here you should be careful about the minus sign here. Yes? Do you remember? We had this before. How should I interpret the minus sign for a mixed fraction? Don't say 2 times minus 2 plus 1. Remember? So let me write it here. 2, 1 over 2 can be viewed as 4 plus 1, 5 over 2. And then if you have a minus sign here, that minus sign will actually be the minus sign for this one. So what will happen? It becomes minus 5 over 2. Then I want to have minus 1. But again, I will use this rule. So what can I do? I can write it as, I can swap them. So it becomes 2 over 5. The minus sign is there. And then you make it positive 1. Yes? Okay, so we continue. And then any number to power 1 is just simply number itself. Yes? I hope that this minus sign is not distracting you. So you see, 2, 1 over 2 is 5 over 2. Because of this minus sign, I put the minus sign. Then I want to raise it to power minus 1. I told you that you can swap them and then make it positive 1. But any number to positive 1 is just a number itself. And I hope that this minus sign is not distracting you here, because this minus sign can be viewed as the minus sign for 5. So you can interpret this as minus 5 over 2. When you replace them, it becomes 2 divided by minus 5. But then you can pull the minus sign out here. Doesn't matter, okay? And then finally, the last one. So let me write it here. So minus 5 over 2 to the power of minus 2. The same story, yeah? So I replace them. The minus sign doesn't matter here. And then it becomes positive 2. But remember, this one should be interpreted as minus 2 over 5 or 2 by minus 5. It doesn't matter. So the numerator to power 2, let us keep it minus 2 in the numerator, and then 5 to the power of 2. But minus 2 to power 2 means minus 2 times minus 2, which is positive 4, and 5 to power 2 means 5 times 5, which is 25. Okay, again, what do I have? For the first part, I have this number. For the second part, without this minus sign. This part, I have this number. And for this part, I have that number. So what is the question mark? Let me glue everything in one place. The first one, I write 9 over 4. Then I have a minus sign there. Okay, what do I have for the second one? Another minus sign here. So it becomes minus 2/5, but minus becomes 2, positive 2 over 5. And then remember, I have a minus sign here, but this one turned into positive 4 over 25. Because of that minus sign, it becomes negative 4 over 25. And then you see that the denominators are different, but hopefully you don't have a hard time to understand the LCD, or the least common divisor, the denominator. How can I find that? It is 100. 100 is the smallest number, which is divisible by 4, 5, and 25 simultaneously. So I put the 100 here because of the first fraction, then I have plus. I put the 100 here, then I have minus. I put the 100 here, and then I try to adjust them. So 4 has turned into 100 by being multiplied by 25. So I have to multiply the numerator by 25. So 25 times 9 is 225. And then 5 has turned into 100 by being multiplied by 20. So I have to multiply the numerator by 20. So it becomes 40. And then 25 has turned into 100 by being multiplied by 4. So I multiply this by 4 as well. So it becomes 16. And now it is fairly easy to do. So I put the common denominator 100, then I have 225 plus 40 minus 16. So 40 minus 16 is 24. 24 added to 225 is 249 divided by 100. But you remember the question is asking you put it in decimal form. Yes? So, and that is extremely simple. The denominator is 100. 249 divided by 100 in decimal form is 2 comma 49. Or of course, if you are writing it in English, 2.49. Yes. And that is the answer that we have to provide here. Yes. Let us go to the next question. Question number 6. Consider the following fraction. If you simplify and write this fraction as a single power, then the exponent, you see I have written it in red and italic and bold to emphasize as much as I can. I'm not asking you for the number, I'm asking you for the exponent of that single power that you are supposed to get after simplifying this number. Okay, anyway, I want to simplify this and put it in as a single power, read the exponent and just type the exponent here. That's the goal of the problem. Okay, so now let us do it here. I mean, this is a very simple task to do. So here, we can do it in two different ways, but I think because at least I want to understand what this number is, because the numbers are not that big, I prefer to calculate this, which is 9, and calculate this, which is 4, and then multiply them, it becomes 36. But of course, you can see that I have two powers with the same exponents. If I want to, I can keep the exponent, multiply the bases. If I multiply the bases, the answer becomes 6, and then 6 to the power 2 again, 36. So it doesn't matter, okay? So let me just calculate it. I hope that you agreed with me that this number is 36. So if you don't mind, let us write it down. So 9 times 4. But what is this one? Minus 2 to power 5 means minus 2 times minus 2 times minus 2, 3 times minus 2, 4 times minus 2. Minus 2 times 2, minus 2 is positive 4. Positive 4 times minus 2 is negative 8. Negative 8 times negative 2 is positive 16. Oh, sorry, I missed the minus sign there. This one becomes minus 32. So this number that you see here is minus 32, but minus 32 times minus 2 becomes what? Plus 64. And then I have minus 19. For the time being, I can write this to the power 3 to power 2 means 3 times 3. But 9 times 4 is, as I told you before, is 36. 36 plus 64 is 100. 100 minus 19 is 81. And 81 divided by 9, extremely simple calculation, it becomes 9. But 9 is correct answer, but the problem is I want you to put this as a single power, and there's only one way to do it as a single power is to write it as 3 squared. But then what I should type is the exponent. So the type, you need to type only 2 in the empty box, yes? Because it is mentioned that we want to find the exponent. Okay, good enough. So let us go to the next question. Question number 7. We want to put this number here, and I told you that if there is no explanation, it means that you have to put the simplest possible form of the number that you see. Okay, let me write it on the board and we can do it together. Okay, you are supposed to calculate this. This is a very simple task, I would say. So question mark is equal to, so 3 to the power minus 2, I use the rule for negative power, I bring it down and make this one to be positive 2. But then 1 over 3 to the power 2, 1 to the power 2 is 1, this also becomes 3 to the power 2. And then the same rule, if I have a fraction and with the negative power, I swap them and make it positive, so it becomes 7 over 9 to the positive 1, and finally minus 1. But this one is what? 1 over 9. This one is also 1 over 9. 7 over 9 to power 1 means 7 over 9 itself. But because all the denominators are 1, I can write this as 9 over 9. I want to have the same denominators. Okay, so the denominators are 9, and I write 1, 9, 1 plus 1 plus 7 minus 9. Then what happens? 1 plus 1 plus 7, 9. 9 minus 9, 0. 0 over 9. Because I want it in simplest possible form, even though 0 over 9 is the correct answer, but there is a better answer to this, which is simpler. If I divide something into 9 equal parts, let us say that I have a circular bread, I divide it into 9 equal parts, but I don't take any of it. So how much bread I have? Nothing. So remember, if you have a fraction whose numerator is 0 and the denominator is a valid number, by valid number I mean a non-zero number, then this fraction is always 0. So the answer to this problem that you're supposed to type in the empty box is just simply number 0. So we type number 0 here, yes? Okay, so let us go to the next question. This question 8, question 9, and question 10 are A-level questions. Okay, this expression is given to you, this equality is given to you, 2 to the 4th times 3 to the 8th equals to 9 to the nth times 6 to the 4th. Then we are supposed to find the value of n. By the way, guessing is not allowed, okay? Whenever I ask you a question, you have to answer it with your solutions. So if I don't see any solutions, but I see even the answer is correct, you will not receive any points because you have to demonstrate that you know the correct way. Because sometimes coincidentally people can get the correct answer, but here you have to show me that you really know what to do. Okay, so let me write the question on the board so that we can continue together from there. Okay, now I have the question here on the board. I start doing it in one way. I'm not saying it is the only way, but that is at least one way to do it. Okay? So here I see that the bases are 2 and 3. Here I have the bases 9 and 6. That would be a good idea if I can make it in a way that the right-hand side also involves with 3 and 2. Okay? So it's not that hard. For example, let me copy and paste the left-hand side for the time being. Of course, this number is not that big. You might think that, okay, it's a good idea to write it 16 because 2 to the power 4 is 16, but finding 3 to the power 8 is problematic, yes? So this is why I don't want to even start writing it. So here, instead of 9, I will put 3 to the power 2, and then I have another power n. But here, instead of 6, I can write 2 times 3 to the power 4. Okay, for this one, I use this rule, a to the n to the m. It becomes a to the n times m. And here, if I have a times b to some power, I can raise the first one to power n, the second one to power n, and then multiply. Let me use these rules. So again, I copy and paste the left side because it's not clear what to do with the left side. But this one becomes 3, 2 times n, so I have to write 2n. But here I can write 2 to power 4 times 3 to power 4. Okay, good. So you see, I want to find this n. What you can do, you can write this the left side as it is, but then this 2 to power 4, I can separate it and write it here. And then this 3 to some power multiplied another 3 to another power, I want to use this rule. A to some power multiplied by a to some power becomes a to power n plus n. So I will do the same thing here. So I will write this product, 3 to power 2n plus times 3 to power 4. So it becomes 3 to the power of 2n plus 4. And now compare. Yes? This left side should be equal to the right side. This is just a copy and paste, you see, 2 to the power 4, 2 to the power 4. So I can, in my head, I can get rid of it by dividing both sides. So then what happens, 3 to the power 8 is supposed to be 3 to the power of 2n plus 4. I have a power with base 3 on the left. I have also a power with base 3 on the right, and they are supposed to be equal. If they want to be equal, there is no other way except that this one should be equal to that one. So 2n plus 4 is equal to 8. So what is 2n? 2n is a number, so that when 4 is added to it, the answer is 8. So it means 2n itself is 4. Yes? 2n is 4 plus 4 is 8. And now I am looking for n. N is a number which is 8, which is 4 after being multiplied by 2. So it is extremely simple to see that n is 2. Okay? So that's an A-level question. So if I go back to the question, you see n equals 2 is typed by me. So what you need to type here is just simply 2. Let us go to the next question. Question number 9 is also an A-level question. If x is a number such that this happens, 3 to the x plus 3 to the x plus 1 plus 3 to the x plus 2 plus 3 to the x plus 3 is 360. We want to find the value of x and type it here. Okay, so let me write it on the board. Okay, so now if I want to solve this, of course, we had a lot of these kinds of problems during the lesson. Okay, we didn't have 360 on the right, but we learned how to simplify things here. So the first strategy, do you remember? The trick was to make the exponents the same, and that is immediately clear. So I will copy and paste the first part because this is the minimum exponent that I have, but 3 to the power of x plus 1, I want to break it into two parts so that 3 to the x appears. This is 3 to the x plus 1. So this is not hard to see that I can write it as 3 times 3 to the x. Why? Because the invisible exponent is 1. If I ask you to combine them, it becomes 3, 1 plus x. 1 plus x is the same as x plus 1. So what I will do next, I will do 3 to the 2 times 3 to the x. What I will do next, 3 to the 3 times 3 to the x. And on the right hand side, I will have 360. But this is now 3. This number is 9. This number, 3 to the 3, is 27. So imagine this way. I have this as a box. Yes? This is again the same box. If I call 3 to the x the box, this is also the same box, and that is also the same box, and that is also the same box. Now look what happens. I have one of these boxes, 3 of the same box is actually added, so far I have 4 boxes. 9 more boxes is added, so I have 13 boxes so far. And then 27 more boxes is added, so 13 boxes I had, 27 more, so it becomes 40 boxes. So the left-hand side is simply 40 times 3 to the x. And the right-hand side is 360. Okay, do I know this number? No. Why? Because I don't know x. But don't worry, because whatever this is, after being multiplied by 40, the answer is 360. So if I ask you what this number is, you can simply divide this by 40. Yes? So 3 to the x is 360 divided by 40. But that is not a hard thing, yes? Zeros are gone. 36 divided by 4 is just simply 9. But I want to answer this question. X is a number, so that 3 to that unknown number is 9. What that number is? Yes, it is just 2, because 9 is 3 to the power of 2. So this means that x is equal to 2. Yes? So, and as you see, x equals 2 is typed by me. So what you need to add here is just simply number 2. Okay, and finally, the last question. This is also an A-level question. Consider the following apparently horrible fraction with huge exponents. This number in its simplest possible form is equal to what? So without having access to the calculator, we want to be able to simplify this huge number. You see that the number is not that huge, but it is formed by extremely huge numbers. Okay? So let us see how we can do it. I will write it on the board and we continue from there. Yes. Okay, we have this number here. I will solve the problem in a way that it is at the level of your course, because if you go to higher courses, might be the simplest way to do it is to using factorization. For example, here, if you go to higher courses, people can simply take 2 to the power of 1000 on. We say we are factoring 2 to the 1000 out. And I will do the same thing here. Simplification becomes simpler, but I want to stick to the rules and lessons during our course. Okay, so I will use the same idea as using boxes and things like that I just explained in the previous problem. As you see, the exponents are not the same, but the lowest exponent is 1000, so I decide to change every other exponent higher than 1000 in a way that I can see 2 to the 1000 the parent. Okay, and that's it. So, but if it's a very long one, so it doesn't hurt if I do them separately. So let us say n numerator is equal to this one. I want to keep 1000, so I have 2 extra 2's, so I borrow 2 to power 2 out. Yes, so it becomes 2 to the power of 2 times 2 to the power of 1000. Here I have 4 extra 1's, so it becomes plus 2 to the power of 4 times 2 to the power of 1000. Here I have 2 extra with this minus sign, so it becomes 2 to the 3 times 2 to the power of 1000. And here, this is already in a good shape, so I keep it. Okay, but then what is this number? This number is simply 4. This number is simply 16. This simply 8. And this simply is just 9. And then what do I give? I give the role of box to this. Yes? Now you know what's happening. I have 4 boxes, 16 more boxes, 20 boxes. 8 of the boxes are gone, 12 boxes left, and I receive 9 more boxes. 12, 9, 21. So the numerator becomes 21 times 2 to the power of 1000, which is extremely huge number. But this is at least the numerator in its simplest possible form. Okay, and now I will go for the denominator with the same trick. So denominator, this is already good enough. So I would write it as 3 times 2 to the power of 1000. The next one, I have 1 extra 2 that I pull it out, so it becomes 2 times 2 to the power of 1000. The next one, I have 4 extra 2's, 2 to the power of 4, which becomes 16, 2 to the power of 1000. And finally, the last one, I borrow 1, 2, I take 1, 2 out because I want to make it 1000, but that 2 that goes out will be multiplied by 5, it will give me 10. The sign is negative, so it becomes minus 10, 2 to the power of 1000. And then again, the idea of the box. So I have 3 boxes. 2 of those boxes are gone, 1 box is left. 1 box plus 16 boxes is 17 boxes minus 10, it becomes 7 boxes. So finally, the denominator becomes 7 boxes. Yes, so that is my denominator. And finally, the question mark, which is the numerator divided by the denominator, becomes equal to, what was the numerator? That was this number. So it is 21 multiplied by 2 to the power of 1000 divided by 7 times 2 to the power of 1000. But then this 2 to the power of 1000 is a huge number, but who cares, because it is gone. And I am left only with 21 over 7. 21 over 7 is extremely simple number, and that is just 3. So what you need to do is to type 3 in this box. Okay, so I hope that this video is useful for you. If you didn't understand something in the quiz, that would be a good opportunity to actually redo the quiz yourself. Whenever you see a question appearing On the display, pause the video, try to do it yourself. If you can't do it, very good, but if you get stuck at some point, you can continue watching the video and understand the problem. Okay, until the next video, be safe and goodbye. Thank you.